everybody, I hope you had an opportunity to watch Generation Genius video on motion and friction. So if you haven't watched that video yet, you might want to pause or stop this video and watch that one first. So what we're going to do is we're going to take some of that information that you learned from that video and we're going to apply it to a very simple lab. Now on my webpage, all of the materials are listed so that you can recreate this at home. All you need is cardboard, aluminum foil, and sandpaper. Kind of easy. Now what are we going to prove, or what are we trying to prove? We're going to try to prove that friction is a force that resists motion. Now I'm thinking back to the ball experiment that we did, and when you rolled that ball across the carpet, remember we said it rolled slowly and it came to a stop, and we talked about friction slowing that ball down. Okay, so let's go ahead and see if the same thing happens in this experiment. All right, so I'm going to start with my cardboard that I kind of made into a ramp, and I just cut this from a box. And I'm going to put this cardboard up like this so it's like a ramp, and then I'm going to put the plain cardboard on here and see what happens. Well, I notice here that gravity is trying to pull it down, but friction is resisting that pull. So right now with a ramp like this, the cardboard's not going anywhere. So let's lift it a little bit further. Not yet. Friction's still resisting. All right, now gravity was stronger than the friction, so the cardboard moved. Now let's try it with the 3 pieces of cardboard. Now I want you to take a look at the surfaces and see which one that you think will fall first. So I've got my sandpaper, my aluminum foil, and my cardboard. So I want you to make a guess, and then we'll see if your guess was right. I know which one I think will go first. All right, so I'm going to go ahead and I'm going to pick this up because right now friction is still holding them all in place. It's resisting the motion. Aha, the aluminum foil. I wonder why. Which one will go next? Oh, I see motion. Wait a minute. The cardboard. And last but not least, now look at the angle that it had to be in order for gravity to take over. All right, so let's take a look at the surfaces. So this surface fell first. Now I notice this is pretty smooth. So if you have one at home that you're using, you might want to feel the surface. It's pretty smooth. And so that one didn't resist as long as the others. So gravity took over quicker. Now this one was in second place. And I notice it's relatively smooth, but I can feel a few like bumps. It's a little more coarse, the surfaces. And so it was second place. And then third place, the one that resisted the longest, this is sandpaper. And if you know anything about sandpaper, it's really bumpy. It feels very rough. It's a very coarse surface. So I noticed that friction is a force that resisted the motion, and I proved it with this. Now, the friction, the more coarse or the more rough a surface is, the more it will resist the motion. Okay, so now I want you to think back to the video when they were talking about the bowling alley and the oiled surface. Now that would really, that would be more like the aluminum foil surface. And that's why the ball rolls so easily on the bowling alley. Now another one would be, another surface I would think of is an ice skating rink. And when you're out on the ice skating rink, it's a very smooth surface and it's easy for you to glide over that surface. Now it's super easy after the Zamboni goes over and puts a layer of water back on there and it refreezes, and it's real slick at that time. And also you can think of a hockey game, how that hockey puck just seems to go gliding over the surface of the ice. So if you want to try this out, this would be a great experiment to do in order to prove that friction is a force that resists motion. So I hope you enjoyed that video. I hope you try this out at home. Keep watching and keep learning.